Hey everyone, here's our lesson in video on writing and graphing linear equations and linear inequalities. So, like usual, it can take a minute to get my pen working. There we go. All right, so this was our second lesson of the first unit, and pretty much all revolves around a single equation as your goal. So, I guess before I get into that, let me go ahead and go through the warm-up that we did. Solve the inequality below and give your solution to interval notation and on a number line graph. So add 6 to both sides, divide by 4, and split. Remembering to flip the inequality and make it negative on your second one. Minus 2 from everything. And you've got your inequality solutions. X greater than or equal to -1, x less than or equal to -3. So on a number line graph, we are going to have circles at -3 and -1. They are going to be filled in circles due to the or equal to. And we can see that x is greater than -1, so greater than is to the right, less than to the left, so this is an outward facing number line graph. Interval notation, -infinity, -3, and -1, infinity. Always make sure you're going left to right from your smallest to biggest or more negative to more positive, and you should be good. All right, so now the goal of all the right equation problems is to get into slope-intercept form. So slope-intercept form is the basics of the basics, y equals mx plus b, something you've probably seen many, many times before. So really the only thing that can go wrong with this form is forgetting which is the slope and which is the y-intercept. So the m is the slope and the b is the y-intercept of your linear equation. Y is y, x is x. So you're really only looking for the slope and the y-intercept. On Schoology, the assignment is going to be a fill in the blank. You don't have to write the entire equation. You're just writing the numbers for the slope and the y-intercept, either in fraction form or a rounded to 1 decimal place. So, all right, on top of that, to get to the slope-intercept form, almost all of the problems have you do the point-slope formula, with a few also using the slope formula. So your goal is to get a point and a slope and then use point-slope formula, and then every single problem is the same way from there. Distribute, combine, done. The only difference is the slope formula you might need to use to get the slope in the first place. The biggest things that trip people up in these two formulas are all those minus signs. So we have a minus up there, minus there, and minus there. That flips the sign when you're plugging in numbers. So it turns negative positive, turns positive negative. So be careful on that. I'll make sure to highlight that as I go through. As far as writing equations, there are essentially 7 different versions of problems. It all depends on how you are presented the information, but they are all solved in essentially the same way. The first 2 bullet points I've crossed off because they're essentially a little too basic for us, so we're not really going to focus on them. Given an equation in unsimplified form, that could be something as simple as x plus y equals 4. You just solve for y. Okay, you isolate y. So depending on how many numbers are going on, makes it a little more challenging, but that's it. Given y-intercept and slope, so like if I say the slope is 3, the y-intercept is 4, that's as easy as saying y equals 3x plus 4. So knowing where to put the numbers. So not really going to focus on those. Okay, the big ones are given a point and slope, given 2 points, given a point and line parallel or perpendicular, and vertical or horizontal. So out of all of these 5 types, the top 4 require the point-slope formula, with the only one requiring the slope formula being given 2 points. In point and slope, parallel and perpendicular, you're all being told the slope. In 2 points, you're not. So you got to find the slope first. The either horizontal or vertical is a little trickier in the sense that it doesn't require any work or formulas. You just kind of have to recognize it and know what your answer is. All right, let's do some problems. Starting out with point and a slope, and then 2 points. So, what is the equation of the lines given the information below? So through the point 0, -1, and the slope is -1. So I have a slope, I have a point. I can jump straight to point slope form. So slope, x value, y value. Distribute the slope, and then combine the last two terms, and you're done. Y equals -1x minus 1. Okay, that's the steps in almost all of these. Some of them, the only difference is maybe you have to find the slope first, like number 2, through the points 0, 1, and -2, -5. So first thing I need is the slope formula. So it doesn't really matter which one you make point 1 or point 2. I'm just going to say x1, y1, x2, y2. So on top it's going to be 1 minus -5, so 1 plus 5. Remember I said that the minus side is going to flip the signs when you plug in. So instead of -5, it's +5, double negative. On the bottom, 0 plus 2. So I get 6/2. My slope is 3. Now that I have my slope, I choose one of those 2 points, either one, and I plug it in and to the point slope formula and solve for my y equals mx plus b. When you have more than one point going on, you can choose either point you want. You normally want to stick with the easiest points. Maybe there's zeros, low numbers, positive, stuff like that going on. But realistically, either point will get you the right answer. So let's say I choose this point. Even though I probably wouldn't, I probably would choose the 0, 1 because it's a bit easier, but let's say I choose -2, -5. Oops, forgot to say m equals 3 over there. So y equals 3, x plus 2 minus 5. So you change the x, keep the y. -2 turned to +2, and y stayed at -5. Distribute the 3. 3x plus 6 minus 5. Combine 3x plus 1, and done. So it doesn't matter which point you use. You get the same answer using 0, 1 as well. So it's just up to you. All right, let's look at parallel perpendicular. So parallel and perpendicular is still a point slope formula. It's just the slope is kind of cryptically given to you. Okay, it doesn't come right out and say this is your slope. It just says parallel or perpendicular, and then you use that to figure out your slope. So if two lines are parallel, then their slopes are equal. So that's basically saying here's your slope. It's just not using the words, here's your slope. If they're perpendicular, then they're called negative reciprocals, which means you take the fraction, flip it upside down, and make it negative or positive. So once again, it's not saying your slope is -3/2. It's saying perpendicular to 2/3, which would be -3/2. Okay, so it's still point slope formula. You just have to be able to identify what your slope is going to be. So let's do one of each, one parallel, one perpendicular. So through the point and parallel to that equation. So that tells me that my slope for the first one is going to be 2. And now I don't care about that equation anymore. I'm not going to worry about it. I got what I needed from it. Now I have a point and a slope, just like this first problem. Okay? Same exact steps from there. Y equals 2, -1. Whoops. Jumped ahead of myself real quick. I forgot the x value, or the x letter. 2x plus 1. Okay, change the x, keep the y, -3. Distribute the 2. Combine, and done. So just because it's parallel perpendicular does not mean it's any extra work. All you have to do is know what it means about your slope. Perpendicular, bottom one, let's see, through the point 1, -4, perpendicular to y equals 1/8 x plus 2. So perpendicular means we're going to flip the fraction upside down and make it negative. So instead of 1/8, it's going to be -8/1, which is just -8. And once I have that slope, I don't care about the equation. Now I have a point and I have a slope, so it's the same process as the previous one. Y equals -8, x minus 1 minus 4. Distribute the -8. -8x plus 4. So exactly the same process once you realize what your slope is. Point slope, put it in the point slope formula, distribute, combine, done. Okay, horizontal and vertical lines. So this is where it kind of frustrates people because you either know the answer or you don't. So first of all, a horizontal line only has a y, so y equals 2 would be a horizontal line. Vertical line only has an x, so x equals -4 would be a vertical line. Now, sometimes you'll be flat out told it's vertical or horizontal, sometimes you'll just have to realize it. So a quick example of what I mean by that. So let's say we have the points 2, 5, and 2, -1. And that's going to be one problem. Our other problem is going to be, let me separate this, 3, 6, and 1, 6. So in a previous problem, I gave you 2 points and asked for an equation, so you calculated slope, you did the point slope formula, and it worked out. If you try to do that here, it's going to instantly fall apart. So slope, let's see on top, 5 plus 1, bottom 2 minus 2, I get 6/0. 6/0 is not a number, it is undefined. Because it is undefined, you cannot use point slope formula. So some people hit a brick wall then. However, go back and look at the points. You see how the 2 stayed a 2. Okay, if the x value did not change, that means your equation is x equals that number, a vertical line. So you can do that without calculating slope or doing any work at all. Okay, no formulas, no calculations, no rearranging, nothing. Just noticing that a value did not change between the 2 points is a guarantee horizontal or vertical line. Okay, same thing down here. The 6 did not change. So we know our answer is going to be y equals 6. It's the y value, it did not change. If you don't recognize that and try to do slope, let's see, 6 minus 6 on top, 3 minus 1 on bottom, I get 0/2. Okay, if a slope is 0, you can't really do point slope formula. If you can't do point slope formula, like I said, some people, it's kind of like hitting a brick wall for them because people want to just do work. They don't want to just have to know what the answer is. So if it tells you it's horizontal or vertical, keep it simple. If it doesn't, check your points. Now, in this case, here's a couple examples where I am combining vertical, horizontal with parallel and perpendicular. So I said like 5 minutes ago that parallel and perpendicular tells you what your slope is going to be. However, if you're parallel or perpendicular to a vertical or a horizontal, then once again it's going to kind of fall apart. You just have to kind of know what the answer is. So through this point, parallel to this vertical line, well, if you think about it, if I have a vertical line, if I want to be parallel to that, it's going to be another vertical line. Since it's vertical, it's going to be x equals, and all I care about is the x value. Okay, no work whatsoever. You just got to kind of know the answer, know it's vertical, and set x equals to the x value. Same deal down here through a point perpendicular to the vertical. So if I have a vertical, perpendicular would be horizontal. Horizontal is y equals, and in this case 3, because that y value is 3. If it is vertical, I don't care about the y value. If it is horizontal, I don't care about the x value. Okay? So don't let it throw you off. Thinking that you have to do all this work, or thinking that you hit a brick wall because your formula didn't work out well. Just know that, it's one of those where you kind of just have to know the answer or not. I'm going to go ahead and work through a few examples that I had you do in class. So if you're unsure about them or you missed them, here we go. I'll try and fit them in as best I can on this window. I didn't leave myself much room. So let's see, number 1. Maybe I'll do different colors for each. Number 1 will be red. So I have the slope and I have a point, so jump straight to point slope formula, -2/3 x plus 4 minus 2. I'm not really going to go in depth into the fraction work. Okay, you can always use a calculator to do the fraction work for you if you're unsure, or work it out by hand. Distribute the -2/3. Let's see, -2/3 times 3 is -8/3, and I'm going to do a common denominator here, so times 3 times 3. -2/3 minus 8/3 minus 6/3, and combine, I get -2/3 x minus 14/3. That's my y equals. Okay, let's choose a different color. Let's go with, not yellow, that's hard to see. How about orange? Orange for number 2. So once again, we have our slope, we have our point. So y equals 7/3 slope, x plus 3 minus 3, to distribute the 7/3, 7/3 x. 7/3 times 3 is 7 plus 7 minus 3, so 7/3 x plus 4. So that one's a little bit easier because the fraction canceled out on the y-intercept. Let's pick another color. How about green for number 3? So for number 3, I need to find the slope first. So let's see, 0 minus 2 on top, -1 plus 4 on bottom, that's -2/3. Hey, same slope as what was above it. And the point I'm going to use is the one that has the 0. So y equals -2/3 x plus 1 plus 0. Distribute the -2/3. And since it's a 0, I don't have to worry about combining. And let's see, let's go with light blue for number 4. Okay, 3, 2 points, so I need my slope first. I'm going to try to cram it in up here. M equals, let's see, -5 minus 4 over -3 minus 1. I get -9 over -4, so 9/4. Not the most friendly fraction. I'm going to pick the number, or the point 1/4, or 1/4, because no negatives. Y equals slope 9/4 x minus 1 plus 4. So 9/4 x minus 9/4. And skipping a step, doing common denominator is going to be plus 16/4. So that is going to be 9/4 x plus 7/4 as my answer. Should be an equal sign, not a negative. And 2 more, a parallel and perpendicular. Let's see, this one, dark blue. So parallel means that that is my slope. Okay, I don't have to do any work to get it. So it's technically easier than number 3s and 4. So y equals -2 x minus 1 plus 1. Sorry, I'm getting a little lag going in my pen here. Let's see, -2x, distributing the -2, plus 2 plus 1, so -2x plus 3. And lastly, number 6, let's go with purple. And if my perpendicular equation is 4 as a slope, then my slope is going to be -1/4. Oops. Sorry, it's starting to lag on me a lot. So y equals -1/4 x plus 4, and plus 0 technically. Distribute the -1/4, -1/4 x, -1/4 times 4 is -1. So there's our 6. And I'll just stick with purple to go on. So that's it for the writing equations. It doesn't get more challenging than that, unless, there's horizontal or vertical, it tries to mess with you, or I throw in some weird numbers like decimals or fractions or something. So moving on to the graphing equations. Hopefully it's not going to lag on me too much. So essentially there are 3 strategies for graphing linear equations depending on your personal preference. The whole deal is that you want at least 2 points on the graph, and then you connect them with a line. Okay, at least 2 points is good enough. 3, 4, 5, just fine. So the first strategy, just plot any 2 points and draw a line. Okay, if you know the x and y intercepts, plot them. Otherwise, just any 2 points. Or plot the y-intercept and use the slope to plot your second point and draw a line. Or make a table of values, at least 2 points worth, and graph them. So for me, it depends on how tricky the numbers are. If it's just standard whole numbers or fractions, I will do the slope or the y-intercept and then the slope. If it is decimals or something weird going on, I will make a table of values. Okay, so it just highly depends on your personal preference. So let's look at an example. Y equals 2x plus 1. So basic whole numbers going on, no fractions, no decimals, no weird stuff. So I am going to start at the the y-intercept. And then my slope is just 2, so I'm going to think of it as 2 over 1. Because, remember, slope means rise over run, which means you go up and then over, or down and over. So up 2 over 1, right there. Up 2 over 1, and I can go backwards if I want. As soon as I have at least 2 points, I can go ahead and connect them. And they should connect with a relatively straight line. Okay. Sometimes the equation might not be given to you in a way that's convenient. So like this one. It's not in slope-intercept form, but you can put it into slope-intercept form relatively easily by solving for y. So minus x from both sides. Divide everything by -2, not just the x or just the 4. So I get 1/2 x plus 2. So now it's just like the last problem. Start at the y-intercept and up 1 over 2 this time. And since it's easy enough on this grid, I'm making enough points so it's nice and neat. There you go. There might be a little bit of matching going on, since on Schoology you can't really make the graph, so you got to do some matching. So you want to use your context clues, okay, to try and figure out which graph is which. Out of all 3 of these equations and all 3 of the lines, hopefully it's pretty easiest to see that only one line has a negative slope. So the green one should be equation 3. Of the other 2, their slopes are almost the same. 2 and 7/5, okay, are kind of similar. So instead of that, let's look at the y-intercepts. One has a 1, one has a 4. So the one that crosses at 1 should be our equation 1. The one that crosses at 4 should be our equation 2. So use your common sense on what the graph should look like, and you should be good on that. Graphing linear inequalities. So instead of a linear line, maybe it's an equality instead of an equals. Just like solving equations versus inequalities, the work doesn't change. It's the representation of the answer changes. Same thing with graphs. Graphing an equation versus graphing an inequality, you will do the same thing as you normally would, except for you might use a dotted line if there isn't the or equal to thing. Then you're going to shade either above or below the line according to the inequality. And then if needed, pick a point in the shaded region and check the inequality. So First of all, a nice little trick thing to remember. If it's y greater than, it shades above. If it's y less than, it shades below. So when it comes to shading, that's all you have to worry about. Y greater than or y less than. So we're going to graph this inequality. I'm initially just going to worry about it as if it's a linear line. Starts at -5, y-intercept up 2/1. I'm just going to put a bunch of points so it's nice and neat. Since it doesn't have the or equal to part, I'm going to make a dotted line. And now y is greater than, so my answer is above the dotted line. The shaded area is called the feasible region. Every single point in there, so let's say I have the point -5, -3, that would be called a feasible point. Feasible just means it works. Okay, so really no more challenging or complex than graphing a straight line. If you have to graph a system, it can start getting a little messy. So I'm going to graph both these on the same coordinate plane, so I'm going to use different colors for each. I'll use purple for the top one, and then maybe green for the bottom one. So starting at +2, down 5/2. And that's pretty much all I can do. Dotted line. And I'm going to shade below it. And let me get green ready. Starts at -2, down 1/2. And this one is a solid line. Now, this one is above. So what we are looking for is where the shaded regions cross. That is the shared solution. So if you look at that, that's in this area. So it starts getting kind of messy. It's that big triangle looking thing. That's where the green and the purple overlap. So what I would recommend is graphing both the lines first, try and figure it out before you start shading a bunch of stuff, so you don't have to worry about getting it too messy and then losing your answer. So that's it for the writing and graphing linear equation. Make sure you rewatch it, ask questions, do what you need to do, and I'll see you when I see ya.